each other.
Yeah. And then let's see the next one. This one was the peekaboo.
Yes.
Yeah. And do we know why they call it that?
No.
No. Just had some
No.
guy in accounting naming these things, right?
Yeah, and a lot of times, I mean, my guess is that with a lot of these objects, they're fairly small, and not a lot of people takes pictures of them. So I haven't seen a lot of photos of either that Little Ring Nebula or this Peekaboo Nebula. And so my guess is if you really worked with Wikipedia, you could probably get whatever name you wanted, which is perhaps what's already happened.
Right. True.
Yeah.
Someone got the sun this weekend, stating the
Yeah.
obvious.
Yeah, that's it. So this is it. Well, actually, I'm going on this cruise, so I'll get more sun. But then summer in Canada is over.
Yeah. Yeah.
So.
I got some sun too, so
Oh yeah, good job.
yeah, I know. I try to hide from it, and this is the Saturn doppelganger. This is a nebula.
Yeah, the Saturn Nebula.
Which is really interesting in just how it looks, because obviously there's some blasted out jets.
Yeah.
It looks not jets, but wind that blew some of that gas and dust in a certain direction.
Yeah, what looks like rings is actually the poles, and you've got material that's blasting out in jets from the poles.
So I should have just gone with my first idea there. Let's see. And then we have this one, which I have obviously magnified, so we don't need to, this one was a full screen image.
That's the filthy one, right?
Yeah, that'd be the quintet. So the quintet's actually down here, and then the, oh gosh,
Deer Lick group is up there.
Is up here. Yeah. But the quintet's down here, which actually is really cool. And so someone asked, are these objects close to one another? And we figured out, no, they're not. They just appear that way, just like the rest of space. Let's see here.
It's really hard to look at these pictures, I gotta say. I mean, I know they're cool,
because
but
you're judging.
I'm totally judging myself, yeah.
I do it too, don't worry.
Jesus, man, this is a family show. I know.
This is the bubble.
Yeah.
And the first one that you got of this one, you were really disappointed with, but this one looks pretty cool.
Yeah, well, this was the second one. The first one was garbage. This one, you can still see a little bit of wind in there. The stars are tiny little dashes, which is bad news. So, but already I know that this was haunting Dustin and Ian, so I'm sure they're going to try and figure out a solution for the wind.
Yeah, the bubble's right here. Guardiono. I'm just gonna call you Guar. Yeah, so that's pretty impressive. And Cali Boy, we will ask him after we go through these. So good that you want to talk about that, because we can definitely talk about that. This would be M33.
Yeah.
And that was a pretty fantastic
nice.
one. Yeah, you can see the arms pretty well.
Yeah, and you can see all the star formation. It's good when I'm actually like looking over the picture. Actually, looks like I'm looking at the picture in your Twitch stream. It's good. Works out well.
Yeah.
That is though you can see all of the star formation, all the little blue bubbles of star formation going off in the arms. I really like it.
Yeah, you definitely can. And let's see here. This would be the fireworks. I like this one a lot.
Yes. Yeah, me too. And this was, again, you can see a little star trailing, but someone recommended it in one of the star parties, and I had never gone after it, and now I've added it to my playlist.
I recommended it.
And although I cut it out, there's that Ghost Bush Nebula there's a Ghost Bush cluster is generally in the same frame, but I cut it out of this picture.
How are these taken? 10-inch reflector with? So the telescope is this. This is the telescope that was used, Mark. Yeah, no, this one's beautiful. I love that one. Oh yeah, then we have the veil.
That one's great.
Yeah,
I think that's the best shot of the night.
Yeah, I'm actually going to take our faces away for a second just so people can see this and how beautiful it is. Yeah, this one's amazing.
I mean, it looks like it's like something is going through water or smoke and leaving this trail of blue and green and red in its wake. But
Mm-hmm.
what it really is the shock wave from a supernova that's exploding. But
Yeah.
I think it's great, and just the really subtle features in there. And again, this is a 3-minute exposure. Just came out great.
Yeah,
So
and behind here, that's what we were talking about being the supernova remnant, right?
no, that's just a star.
Okay, so what was Dr. Pamela was mentioning something like, is there a remnant behind it? I believe. Maybe
Not
I'm
in this one.
not
So
in this one.
if you like zoom way out, you can't zoom out of this picture, but if you zoomed way out, this is just one edge of this entire supernova explosion. So this is one portion. They call this the witch's broom, but there's
Right.
another part called the Eastern
The
Veil,
Eastern
and
Veil.
there's another part, and they look like this circle. And this
Mm-hmm.
is just one little piece of the circle because the object is so big. And what it was a supernova that went off a few thousand years ago, and we're just seeing the wreckage. And I don't know if we know where the actual supernova remnant for this explosion is.
Awesome. Yeah. And someone said there's more tabs open than stars in the universe. Okay, there's a lot of stars in this picture. I don't know if you guys know that, but I don't have that many tabs. All right. Here's the edge on one that we got. So NGC 891. Isn't this
Yeah.
one like 30 some million light years away?
Light
I
years away.
believe.
Yeah. But again, I like it. Again, you can see a little bit of star trailing, but I really do like the object itself. It's just because you can see the bulge, the dark lanes of the of the uh, of the spiral arms, and into the disk of the galaxy. It's great.
Yeah. And this
And
one is.
apparently, Pamela was telling us that because the bulge is not very big, it actually doesn't have a very massive, supermassive black hole.
And
Which
that
is
makes
pretty great.
sense. So,
Yeah.
supermassive black hole obviously has a relation to how big the bulge is.
Yeah.
I'm sorry. Yep. We're just moving
You
on through
learned a
that
new
one.
thing.
So yeah, this is 30 million light years away. So that's that's a long
That was not the
distance, guys.
farthest one that we saw, though. Those galaxies in the Stevens Quintet are much farther.
Yeah. Way. Oh yeah, here's Andromeda. And again, I'll take our faces away just because these are the things that people really like to see, and
Yeah.
and with good reason. Wow, I just totally did that wrong.
Andromeda is a rough one to take a picture of. We were going into all the detail about this, that because the core is so bright that you've got to choose. Do you want to image the faint spiral arms, or do you want to try and get some features in the core? And all the pictures that you see, when you can see both, somebody has taken a bunch of pictures and they have stacked them up so that they can show some features in the core, and they can show some features in the spiral arms, and it's a composite picture.
Right. And so down here is M110, right?
Yeah.
Yeah. So that's
And
super
then
cool.
and M32 is just above, to the right.
Just above to the right. Am I too zoomed in?
No, the little blob. That one.
Oh, this one right here.
The one. Yeah.
Yeah.
Yeah. So that's M. That's M. So M31 is Andromeda. M32 is that little blob beside it, and M110 is the one at the bottom. And M110 is the final object in the Messier catalog.
Oh, that's
Right?
interesting.
There's only 110 objects in the Messier
Right,
catalog.
that's right.
And there's no 103. No, 102. There's no 102.
Why did they skip 102?
Messier, when he made his list, was making this, like, Messier was a comet hunter, and he was searching for comets, and he wrote down all of the objects that had kept fooling him each time he went out to sea. So all the Messier objects are only visible essentially from the northern hemisphere, from where Messier could see from his perspective. And there's lots of things that he listed which really aren't that bright, and other objects that he should have listed which are very bright that he didn't include. But the list, he was like one of the first lists of deep sky objects, and so it stuck.
Yeah, he was looking for fuzzy things.
Yeah,
he thought those were
and
comets.
the NGC catalog is a much more useful, comprehensive list of things. But even that is missing all kinds of objects as well.
Yeah,
because they didn't have the capability to see the the fainter nebulae that we can see today, and so they didn't know that those things were there.
Yeah. Ooh,
So
the
that's why there's
iris.
the Sharpless catalog, which is a whole other
A
catalog.
whole nother catalog.
Yeah.
Here's the iris.
Yeah,
This
that was
one-
nice. That's such a great nebula.
Yeah. That one's pretty.
Yeah, and so it's just surrounded by all this dark nebula material, and then the star right at the middle illuminating this blue glow.
Oh, man. Yeah. It's amazing. And oh, here we go. Yeah, because see, I couldn't see this. It was kind of weird on my screen, but here we. Yeah, this is the elephant trunk.
Yeah, and that's clipped in pretty small. It's actually a pretty large structure with a lot of dark nebula and other nebulosity.
Yeah. So this one, I mean, you know, if we can capture this one, don't you think the horse head would be okay?
I don't know.
We'll have to see.
Yeah, that's what we're gonna have to find out.
Yeah, that one's awesome. Here's the dumbbell nebula.
That's a good one.
That's a great one. That is
Yeah.
a great one.
Yeah, I love that the shape. I love the green and the red right at the very edges of it.
Mm-hmm.
And you can see it almost starting to like burst out of the top and bottom of the dumbbell.
Mm-hmm. Yeah.
Yeah, the apple core.
It's a beautiful planetary nebula. What camera do you use? Oh, there's the telescope right there.
Yeah.
Yeah.
So
Ooh,
this one's different. It's a smaller resolution camera, but the pixels are bigger, and so it can gather a little more light. The goal was to make this thing fast.
Yeah, and it is fast. I mean, we took this many pictures. I think we did this for what, like a little bit over.
Just over 2 hours.
Just
I think
over
about 2.5
2 hours,
hours
yeah.
by the time we were done, and I had just shy of 40 pictures in the.
That's really impressive, guys. In case you don't know, that's super impressive.
Yeah.
But this is a beautiful cluster. This one would be M13, yeah.
Yeah, that's the great globular cluster in Hercules.
Just a few stars.
Yeah, a few 100,000 stars.
Few 100,000. And yeah, we have the Ring Nebula here, I believe. Yep. This is the Ring
And
Nebula.
This is where we had that argument about that little central star.
It's gotta be.
And it is the white dwarf at the middle of this thing.
Nice. What was the longest exposure? I think we did a 5-minute, right? That was the
We
longest.
did a 5-minute, and it was a disaster. Yeah, we did a 300-second exposure of the Heart Nebula, and it just didn't work.
Yeah. Here's the Eagle. This
That one
one's
worked.
amazing. And you can even go, I can zoom in a bit so you can actually see the pillars of creation. But yeah, that one turned out fantastic. First globular I've ever saw, and I started my obsession with them. Yeah, they're pretty cool. That's God's hand. Tabs, see? Everybody's freaking out about tabs.
Yeah, I know.
I knew
You
it.
should be closing the tabs as you show the pictures, but maybe you're going to want to show the pictures again later on. So I understand.
Yeah, no, I just didn't want to lose and I just did it anyways. But I'll close them later.
No, I think it's great. I think you're trolling. It's just like let people
know.
just feel this tab anxiety.
Yeah, and Skynet knows they know I like my tabs.
Yep.
That's
Computer
gorgeous.
can handle it.
Yeah. Right now it can. So yeah, this would be the Omega, right? Nebula. Sorry,
Yeah,
guys.
also known as the Swan.
The Swan. Let's see. This one. So what's really cool about this one, I was talking to people about it. So this one's actually a hybrid of absorption
it's
and a
terrific.
dark.
It's a emission and a reflection.
Right. So yeah, right. So I usually say it's right. I'm sorry. Absorption equals dark. So sorry, my brain's not working. I woke up way too early.
It's not an absorption. It's a yeah, that's right. So this isn't an absorption, although there's regions of absorption. You can see them inside of it.
Mm-hmm. Yeah. So the
where the
emission is
dark
like the
lanes are.
red, and the reflection
Yeah.
would be that blue part.
Right.
Yeah. So much red and blue. Yeah. But that's why this is cool. This is kind of a combination of two different types or categories, you would say, of nebulae. But
Yeah.
you get it in one. So that blue again is the reflection. And that's where, the stars inside of it basically light that gas cloud up. And then on the emission side, that is completely different. That's the red. It's you have two
It's
different
so
things
hot that
going
it's
on.
glowing, while
Yeah,
the other one is not hot enough, so it's merely reflecting
right.
from the hot glowing.
Would be cooler if. Oh, okay. Let's see here. So this one is the lagoon, which is always amazing to look
Yep.
at. This one's always great.
Again, it's always a tricky one because that central star forming part right in the middle is so bright,
Mm-hmm.
so much going on in there that you've got to decide: do you go after that region, or do you try to get some of the fainter, subtler parts around it? But it's almost as nice as the Orion Nebula.
Yeah. And here's M101. This one turned out the arms on this is amazing.
Yeah, yeah, the pinwheel.
Yeah. And I'm gonna take away my face. You
And I
don't need.
love that it's not balanced, so you know that it got into some trouble billions
Mm-hmm.
of years ago. You can see that it had one of its arms torn off.
Yeah. And you can
So
see some
something
of the
happened.
there's some star forming regions on the outskirts of the arms too.
Yeah.
Um,
Yeah, and some of those are actually they get NGC designations all on their own. They're so bright and so um, observable
yeah.
that there's even some in Orion. Oh, sorry, in Andromeda as well, that are their own separate designated objects because they're big and bright.
Yeah. And this is the whirlpool, right?
Yep.
Yeah. Which I just tried to show in Space Engine, but it doesn't show it being in the process of eating that other galaxy, that other dwarf galaxy.
Yeah, it's
Dwarf.
funny. They don't do a proper, like, that's its most important feature, and it's weird that
Right.
they haven't got that simulated. You should reach out to the developer and ask them what is going on.
Yeah, because this is super cool and that you can see something like that.
He can use our pictures if he wants.
I know. I
Yeah.
know. He was stealing them. He even said that he said, I'm gonna post these in the Space Engine Discord. And I was like, go for it. But what causes that whirl? Guar asks.
So what causes the whirl of galaxies?
Mm-hmm.
So the thing that's really important to understand is that those spiral arms that you're seeing are not actually, those spirals don't move around the galaxy. They're what's called a density wave. And what's happening is the stars are going into this region and they're piling up almost like a traffic jam. And so you're seeing the dense regions of these stars, and then the stars come out the other side and they spread out again from these density waves. And so stars take turns going through these spiral arms. The spiral arms remain, but the stars that are in them are different.
Yeah.
And so the star, like, the interesting thing that happens with galaxies is that, unlike in the solar system, right, when you look at, like, Mercury is going around really quickly around the sun, while the Earth is going more slowly, and Pluto is going the slowest of all. But actually, all the stars in the galaxy, they're all moving at the same speed.
Right.
So even if they're close, they're moving the same speed, and if they're far, they're moving the same speed. And it sort of causes it causes this very strange view of all the stars moving around, and that's because there's this much larger halo of dark matter that's controlling the way the whole galaxy's stars move. But it's great to think that those spiral arms, like, the galaxy isn't turning and those arms aren't turning. It's that the arms are just this persistent density wave that
Yep.
the stars move into.
Yeah. Did that answer that, Guar? And this was the first picture we started off with.
Alberio.
Yeah. Which is really cool because what I love about this is that you can see the color of the stars being different
Yeah.
substantially.
Yeah. One is blue, one is yellow.
Yeah. And that's amazing. So we got these and again, we did this in under, 2 hours or around 2 hours, a little bit over.
Yeah.
Wow, they really move at the same speed. Yeah, that was kind of one of the things that kind of said there must be something out there, like dark matter.
Yeah, that was Vera Rubin's amazing discovery, the one that really showed that dark matter was something, anyway, a mystery.
Mm-hmm.
Because you would expect a galaxy to work like a big solar system, but it doesn't.
Right. Is that a binary system? It is.
Yeah, it's not.
Well, wait, no, it's not.
It's a visual binary.
It's a visual. They just that
Yeah,
that just
so they
got
look
changed.
like they're side by side, but they're not actually gravitationally bound to each other.
Yeah, there's no they don't move at the same horizontal speed, they move at the same rotational speed.
Right. So they're moving. So each star is moving at the same speed. I don't know what that speed is. Whatever, several hundred kilometers per second. And if they, whether or not they're close or far, while say the Earth moves at 30 kilometers per second around the sun, while Pluto moves just, I don't know the number, some 5, say, while Mercury is going, say, 60. But in a galaxy, all of the stars are going the same number, 300 or 500 or whatever that number is.
So
And
which one?
so,
Oh, I'm sorry. Go on.
no, go ahead.
I was going to say, so which one was your favorite?
I think the Veil was my favorite.
Yeah, the veil was pretty amazing. I'm actually going to bring the veil up.
But I did like being able to show Dustin and you a bunch of objects that nobody that they had never seen and never imaged. I mean, that's part of the fun of it. Is there are, let's say that there's 50 zingers up in the sky at all times, but then there's another 200 or 300 which are interesting and I've never seen before. And so it's fun to just try out these new objects. And every now and then, like I'd never imaged that edge on galaxy before. And some of the stuff you just don't know. You think you can't get it because it's too small, it's too faint. And then it's surprisingly interesting when you actually capture it. So I try to go after a bunch of new objects every time I do this, just to know what's out there and what's good and what's garbage. And sometimes, like, if people follow me on my Twitch right now, that's what I'm doing. I log in and we just go through a constellation, object by object. Like, is it good? Does it suck? I don't know, right?
Right.
And I get people's, what people think. And so it's not. Last night I was just going after the hits, right? I was playing the hits on the playlist as opposed to going after, just trying to comprehensively discover what's out there.
Yeah, and someone said, are there plans to use a telescope setup in the southern hemisphere? Soon,
Yeah.
TM.
Yeah. So, I mean, I pitched this idea to Dustin maybe 3 or 4 months ago. And so he created he built this one observatory and he originally put in that refractor, and it just wasn't fast enough for him. So I was happy with it. And actually it's a little more stable. It's a heavier telescope. It doesn't wobble in the wind in the same way. But then he built a second observatory in Texas and has just got it operational. And now he's planning to he's going to put one in the southern hemisphere, maybe in Australia. Wants to build a sun telescope, and they're even working on a space telescope, which I'm sure we'll be able to bring into the Star Party once that's operational.
And there was another question that I wanted to say for you that I don't know if Cali Boy is still here, but he asked about. So when we were talking about supernovas, obviously we're thinking Betelgeuse is a nice possibility, but also there is that one, the V1309 or the KIC number. I don't want to have to. It's like a license plate. That's supposed to go off in 2022.
Well, apparently that's now a mistake.
Yeah, that's what I was just reading on the Wikipedia page.
Yeah.
As of this month, actually, right?
Yeah. So someone had there was a typo somewhere in it, and they thought that the two stars were going to collide in 2022, and now it looks like they won't.
Yeah.
Oops. Typo.
Happens, guys.
Yeah. And it wouldn't be a supernova. Well, it would be. We don't know what it would turn into. It would definitely brighten in the sky. What's that white line in the top right? Space border? That's a satellite.
Satellite.
Yeah. So I would throw this frame out if I was building if I was like taking hours of data. I would take that little zip through and I would go, nope, garbage, and throw it out. But
yeah,
it's just for the Star Party. So
yeah, there was a question last night. Oh yeah, some guy was spamming this question, and I want to see what you think about it. Where is the 0 point on the coordinate system in the universe, or can you go more into the coordinate system explanation? So a 0 point coordination. That was spam. Like, two other guys just got in on spamming it, and I was like, hey, I had, that's what the point where I had to mute everybody and say, like, I got it. Like, I heard.
So what was so was this last night?
Mm-hmm.
And so I don't understand. So what was the question?
Where is the 0 point coordinate system in the universe? Probably asking fancy, where is the center?
There is none.
Right.
Yeah.
Fancy way of saying that, by the way.
Yeah.
Really fancy.
So I just dropped my new question show and had the same covered kind of that question in it.
Mm-hmm.
And so people are always imagining this explosion, right?
Right.
And the way that I always describe it is, don't imagine an explosion. Imagine a grid, a 3-dimensional grid that goes on forever. And at the beginning of the universe, the space between the grid was very small. The universe was very dense. And then the expansion happened, and the space between the grid got bigger, and then the universe was less dense. But imagine if it went on forever in all directions. Where is the center of that? It's forever.
Mm-hmm.
So,
Yeah.
and it could very well be that the universe is finite, and if it's finite, then just imagine a 3D game of asteroids where you go one direction and you come out the other side, right?
Mm-hmm.
Go out the left and you come out the right. Go out the top and you come up the bottom. So
Yeah. And Napfan asked a good question, and that was, I just lost it. It says star collision should produce gravitational waves, shouldn't it? If it's massive enough. So, like, we saw the neutron star collision. That wasn't packing as much energy as, say, the black hole collisions that LIGO had observed. And that's why it was so insane that they could detect the neutron star collision. But you have two massive things, right?
Squeak Addict has a great explanation. It says so the spreadsheet is the same size, but the cells are larger. No, the spreadsheet is bigger. The spreadsheet goes on forever, so it's still forever.
Infinite
but
spreadsheet.
the cells are larger, which is exactly right.
Kelly Boy said, what happened to the first universe in space? Where is it at now? The first universe?
Huh? We don't know. We don't know what came before. All we can do is run the calculation backwards until you get to a place where everything is really, really close together. And then you don't know what it looked like before then, and you don't know what set it off, and you don't know what came before. That's a whole other question that nobody has figured out. So people always have this misnomer about the Big Bang, right? The Big Bang is just, it sure looks like the universe is expanding.
Yeah.
And you can run that expansion backwards to a point that we can't measure it anymore. And then at that point, you go, well, that's that for that theory, right? We're done. That's as far as we can go. A whole other theory is like, where did that come from? It's the same thing with evolution, right? We have absolute concrete proof that evolution is a thing, and that it's happening, and that life forms are changing, and that everything is connected. And you can run the clock backward and figure out when every life form on Earth went on to its own separate branch of life. That doesn't explain where life came from, and it's not its job.
Mm-hmm.
Who cares, right? It's not evolution's problem to figure that out. That's someone else's problem.
Yeah. So someone's asking a question: is the universe flat or hollow?
Well, it's flat in that, like, here's the way to think about this, right? Look at the Earth, and if you start off with two parallel lines on Earth, they will sort of, if you go towards the poles, they'll if you start, say, at the south pole and you start with two parallel lines, they will move apart and they'll go around the equator and then they'll come back together, right?
Mm-hmm.
So if you look at the universe, so that tells you that the surface of the Earth is curved, the way the parallel lines move. But if you go into space and you take two parallel lines and you shoot them off, they go on forever, perfectly parallel, which tells you that space is flat.
Yeah. It's like a donut, right?
Well, maybe. So
Maybe.
the question is, what is a topological structure that is 3 dimensions that would allow for things to be flat? And so a sphere. So the universe can't be a sphere because a sphere isn't flat, right? If you have, as we said, if you have two lines moving on a sphere, they curve. But a cube. The universe could be a cube
Right.
because two parallel lines will move along on a cube and remain parallel, or a 20-sided die, or a donut. And the donut is the perfect example, as you said, because draw two lines on a donut anyway, go around the donut part, go, you know,
Right.
around the side of the donut, and your lines will remain parallel. And so astronomers have tried to figure out what are some possible topologies of the universe that both match the flatness that's been measured and yet are also three-dimensional objects that are possible.
Yeah, so Electro, he just answered that. Yeah. So does the shape of our universe depend on its density? Let's see. So why are humans evolving exponentially?
Well, I mean, it's information, right? I mean, we're not evolving exponentially. If anything, our evolution is sort of
Slowed
slowing
down.
because we've removed a lot of the pressures from nature to change us.
Mm-hmm.
So before, people who say had birth defects or other kinds of things would have died off, and now we have medical technology that allows a person with, say, diabetes to live a regular life. But when you think about just human culture, I mean, that's the part that's increasing exponentially, and that's all thanks to us communicating, thanks to the internet.
Zeno says that's not proven. No, people are living longer. I mean, you have ways of yeah. I mean, that's, yeah.
Yeah, we live longer. We
Yep.
live longer. We would both be dead
Yeah.
if we were back in the Neolithic age. I would definitely be dead. um, and you would be an old lady.
Yeah.
And now it's a totally different story.
Yeah. That's very different. Let's see. Would you say humanity needs conflict in order to evolve? Wow, this is turning a little bit into philosophy.
So, sorry, what was the question? Needs conflict in order to evolve?
Mm-hmm.
I don't think so.
Resistance.
I mean, we live. I haven't read the book, the Pinker book, but I want to. But I know, but essentially, the world is getting better than it's ever been. That the death rates are lower, the poverty rates are lower, the level of education is higher, the amount of wars are lower than have ever been. The people have died from war, from terrorism, from various kinds of diseases. So by every way that you would measure, is the world getting better? It's getting better and better and better. So is that, like, is that going to keep on accelerating? It's a funny question to be a part of. We're in the middle of it, and so we're experiencing this transformation as part of it. But we live such good lives compared to the poor saps who came before us.
Yeah. Iron says, why isn't finding out what happened before the Big Bang your job to solve? Wow.
Yeah.
Wow.
Yeah. I mean, it's like you're a mechanic and someone says the brakes don't work, and then is it your job to go like, I wonder if this is the best kind of way to have brakes? Could there be a better form of brakes? Right? Do we even need to brake?
Do we even need brakes?
Do we even need brakes? Like, this is one of those fundamental philosophical questions. And so if you came to the mechanic, you're like, the brakes aren't working. You're like, yeah, but what is braking?
Yeah.
And I mean, what is your speed compared to the background motions of other galaxies, right? Are you really braking, or are you always just accelerating? And you're going around the Earth at 1,000 kilometers per hour. Does braking even mean anything at that kind of speed?
Yeah.
So, yeah. So the point is, you take a problem and you break it up into pieces, and you deal with them one at a time. Deal with the car's brakes don't work, then deal with what is the existential meaning of braking.
Exactly. It wasn't a hostile question.
No.
Okay. We weren't really. I was just making jokes.
No, but I think I mean, that is a response that a lot of scientists get, right? Which is like, you can't explain where life came from, therefore evolution is nonsense.
Right.
And that's like ridiculous, right?
Yeah.
Just because you can't explain it. And again, I like to use an analogy, right? Like, You know, you go to the store and you buy apples. You can't explain where what tree and what farm those apples grew on.
Right.
Like, I know that if I go to the store, there will be apples there, and I will buy them, and I'll bring them home, and I'll eat them. And that is my theory, my working theory of how I get my apples is I go to the store and I buy them. And just because I don't know where those apples came from before they got to the store doesn't invalidate my theory that I go to the store and I buy apples.
I guess a better way he said to word that is, do you want to work on that question or do you not care?
Yeah.
Well, yeah, no, any
Yeah.
question like that. I mean, these are the things that we thrive off of, that we wonder, you know, like questions are great. Questions are amazing. I don't want answers to all the questions because then you don't have any more questions.
Yeah. Yeah. As you said, right, there are some questions you can just kind of nibble on the edges of them for a while.
Yeah.
And that's what astronomers and physicists are doing. And other questions are fundamentally complicated, and there doesn't seem to be any easy way to get at the evidence. And it could very well be there are a set of questions like what came before the universe, or what is the ultimate fate of the universe, or that we may never know the answer to.
Right.
We always have to make do with I don't know. And that's all we can ever say is I don't know. And so the problem is a lot of people have some why they think they know, right? Because of a book or because someone told them a story.
Clickbait YouTube stuff.
Yeah, they watched a YouTube video and someone told them what came before the Big Bang, and they think that that's a reason why to believe something. And so whenever you say that you believe in something, you have to say, like, what is the evidence that supports what you believe? Why do you believe this thing? And if the evidence isn't good, then you shouldn't say that you believe it because of that evidence. You should just say, I don't know.
Right.
Is there a God? I don't know.
Yeah. I don't know. I'm so comfortable.
I am unconvinced at the evidence that anybody has submitted to me thus far in the existence of anything. So you just say, I don't know. It's the honest thing. Because then it puts it back to the other person, right?
Right.
So you say, someone says, where did the universe come from? You go like, I don't know. And then they go, well, like, I know. You're like, oh, do you? Okay. So how do you know what you know?
Yeah.
And they say, well, which that sounds like Astronomy Cast.
Have you ever seen Ancient Aliens? Okay, bro.
Yeah, I saw Ancient Aliens. Yeah, a book told me. I sat one day and I thought it through. Okay, great.
No,
right on.
Yeah, it's like people get uncomfortable with the whole idea of I don't know, and I think once you embrace the I don't know, it does take a little bit of toning down the ego a little. Because but that's what makes this stuff good, and it's very humbling. That's why astronomy is amazing, because there's so many I don't knows, and you realize, wow, it's pretty cool that I can think about these things, and that's unique in and of itself, that I have the gray matter, the capacity to think about it, and to wonder about it. Love that part. But in terms of space, it's so beyond us, but we're curious. So
well, you say, I don't know. Let's find out.
Yeah.
Right. I don't know. It's a fascinating question. I think we should explore our curiosity and see what we can find.
Yeah.
And if new evidence shows up that shows that what I used to believe was wrong, awesome. I can't wait. Right. I'd love to, because then I know more and I knew less before. And changing your mind is a great way to approach this stuff as well. So,
yeah, and that's science.
Yeah. And so I think that people say like, oh, you're not open-minded. I'm 1,000,000% open-minded. I can't wait to find out. Your theory about UFOs has not convinced me yet.
Right.
But keep trying. Like I would love to believe, but I want to know that the answer is that I'm really believing for a good reason, not a mediocre reason.
Absolutely.
Because I heard a story about a guy who said something once.
Right.
Who saw something.
Yeah.
Right. That's not a good reason to believe in something.
Exactly. Do you think people from different galaxies are looking at us? Wow, that's a very interesting worded question.
Well, right. So, I mean, different galaxies, probably not, although maybe, right? Because we are looking at other galaxies and potentially looking for aliens. Astronomers have actually done a survey of other galaxies looking for type 3 civilizations that have enclosed all of their stars into Dyson spheres, because it would give off a very specific wavelength of infrared radiation, you would see them. And so we've actually done a survey. So you would assume that other aliens, if they're out there, have done the same thing. But there is absolute concrete evidence that there is aliens here, or that there is life here on Earth. And any alien within a few hundred or maybe even 1,000 light years would have the ability to see with their telescopes that we're here. And they would see the impact that our oxygen is having on the atmosphere, the other trace gases. If there's aliens out there and they're within a few thousand light years of us or more, right? They know we're here. We're about to develop those telescopes in just the next few decades. They just broke ground on the world's biggest telescope, the extremely large telescope, and it's going to be operational by 2025.
And
And
guys,
it
he
will
actually just listed the name of that. So he's not just, throwing in fancy adjectives, or actually that'd be an adverb, extremely.
extremely, yeah, that's the actual name of the telescope. It's the European Extremely Large Telescope, as opposed to the Very Large Telescope,
Right.
and the canceled Overwhelmingly Large Telescope. And I'm not making those names up. They are the actual names of these telescopes.
Those are the names of the telescopes.
Yeah.
Someone said something pretty interesting that made me think of a certain, I'm scared of I don't knows. There was something I was going to ask you. Oh yeah. So a lot of people, obviously this is going to trigger like, so do you think that life is out there and whatever? And I'm curious on your opinions, Fraser, what you think about, like, why are people, so obviously on a scientific level, there's a reason that we're interested in finding extraterrestrial life. Be it intelligent or be it, sorry, I'm not even thinking of the word right now, microbial life. So why do you think, there's probably a few reasons, and I'll let you list a few. Why do you think there's such an urge, or why is this like a hot topic?
Sorry, which is the hot topic?
To find life. Why do you think that people are so like that fills up a lot of our questions? Like, do you think life's out there?
Yeah, well, I guess the thing is like you go back to the Arthur C. Clarke quote, right? Either we're alone in the universe or we're not, and both possibilities are terrifying. Right? So if we're alone in the universe, then we are the only place in the entire universe that has intelligent life. And if we wipe ourselves out, which we could very well do, that was it. That was the universe's chance to have. Oh, my child's trying to reach me. I'll get back to him. If we're alone in the universe, then it's our job. And if we wipe ourselves out, then nobody will be able to explore the universe. The universe will just go on and just be dead forever, which is kind of sad, right?
Yeah.
But if the universe is filled with aliens, then where are they, and how long until they show up and wipe us out? So that's a weird and kind of terrifying thought. But just at the end of the day, knowing the answer to the question, are we alone in the universe, is the most fundamental question that humanity can ask, I think. We want to know if we're alone in the universe. Where is the other life? And I always like if I could give you an envelope, and in that envelope was the answer, would you want to open that envelope and find out? Right?
Yeah.
So I know the answer, I'm God or whatever, and I write down yes or no, and then I put it in an envelope and I give it to you. And I'm like, for anyone who then goes like, I don't care, it's a stupid question, I don't want to know. I'm like, well, the answer is in that envelope. So you decide whether you want it. That's called curiosity.
Right.
So the thing is that we don't know. We don't have the easy way. No one put it on an envelope for us. So we have to go the hard way, which is we have to build gigantic telescopes. We have to spend space missions out into space, and we have to observe other planets and search carefully, trying to build up evidence to come up with an answer.
Here's the question, though. So if that envelope said, yes, microbial, how many people would be like, wah, wah, wah?
Wah, wah. Yeah.
I wanted something super cool with big eyes that can communicate and that's already gotten faster than light travel. And with Dyson spheres, so do you think like a lot of people would be receiving that the same? I'm curious also with
I
chat if you
mean,
guys would be.
some people would think that was sad, and some people would be like, well, now the universe is ours for the taking. And so I think every single possible answer to this question is fascinating,
Yeah.
right?
Right.
So that's the magic of it, I think.
Right. I think a lot of people, a lot of people that, microbial, I think would be absolutely amazing. So, but
Yeah, where
still,
did it come from? How did it get started? Is
right.
it like us? Are we related in some way? Does it
Right.
have the opposite? Does it use DNA or some other mechanism? Is it made with carbon or some other organic molecule or some other kind of is it based on some other atom entirely? What what kinds of conditions did it possibly form in? Yeah, absolutely.
Yep.
What is the most advanced that it's gotten to? Why wasn't there more multicellular life? There's a million questions that you would
Right.
then ask.
Yeah. So I'd be totally
So
fine with
I'd want
that.
another envelope.
Yeah, I know. What if the aliens want to help the ants on the planet before they help us? We're ants to them after all. It's only fair. You want to answer that one?
So what if the aliens come and they want to speak to the whales?
Yeah, they
And
want
if
to
we
talk
don't
to
have the
something else. They
whales,
don't even.
then they're going to wipe us off the surface of the earth. We better go back in time and find some whales.
Microbial would be the easiest to study too, right?
Um,
That's
maybe. I
maybe,
mean,
yeah. That's
not exactly. Maybe you had like some kind of alien dinosaur, and you could like go over and just watch it running around the landscape. That would be fascinating.
So. What do you think, Fraser, of the multi-universe, multiverse theory?
Well, the multiverse theory was created as one of the outcomes of quantum theory. And so one of the possibilities on how you can get weird outcomes from quantum mechanics is to have other universes created. This is the Copenhagen interpretation. And then one of the other things that's interesting is that the whole concept of inflation, if inflation does prove to be true, which there's some pretty interesting experiments that are going to do that, they demand other universes as part of that theory. So there could very well be other universes. The problem, of course, is that we'll never be able to directly detect them, never be able to travel to them, and so they'll always have to mostly be I don't know.
Yeah.
Yeah.
And someone asked earlier what your profession is. So he's a comp sci guy, just like I'm a comp sci lady, and we both really like astronomy. And he's made a whole thing. He's the publisher of Universe Today. And
Yeah, I've been a science journalist covering space and astronomy for just shy of 20 years. So that's what I do as a job, is I report on space and astronomy.
I would tell the aliens they shouldn't visit because our people get obsessed and dangerous with people who play video games for a living and broadcast it.
Right. Yeah, we can't have that. I'm sure they've already gone through the whole Twitch age, and they can come back and tell us the dark future that awaits us. And they'll have their own stories about their own version of Ninja.
Do you think we're at the forefront of evolution on a universal scale or in the middle percentile? That's a good question.
Well, we missed the party, right?
Yeah.
So the actual time when star formation was happening, when there was lots of really interesting stuff happened billions of years ago, and now everything's settling down. We're in the retirement phase of the universe, and it's still got its long future. So we're at the end of life, new formation of life being possible. But it all depends on how things work around the red dwarf stars, because they're going to last for trillions of years. So who knows?
Yeah.
But the usable energy is rapidly running out, and we've missed most of it.
Yeah, star formation's not as popular as it used to be, guys. And Fraser, do you think with the upcoming launch of James Webb Space Telescope that we will be able to see beyond our current observable universe?
No, you can't still see beyond the observable universe. It's baked right into the name.
Yeah.
It's the universe that can be observed. And when you look out and see the cosmic microwave background radiation, you're seeing the time when light could finally escape. So if you go back to the beginning, we talked about that, how we have that grid, right? The grid was compacted so tight together that the matter was everywhere and it was hot. The entire universe was the temperature of a red dwarf star. And so no light could get out. And then finally the universe got non-dense enough that light could finally start escaping. And now we're seeing the light that's getting out there. That is the moment when you can't see any farther with light.
Right.
The only way around that is you could potentially see that extra 300,000 years by using gravitational waves. And so one of the instruments that's in the works right now is called LISA, which is going to be this orbital gravitational wave telescope. And then the one after that is going to be called the Big Bang Observatory. And it's going to be 6 spacecraft satellites flying in formation that will be able to detect the ripples of the universe right after the Big Bang. And so that should allow the astronomers to peer right to the moment of the Big Bang.
Yeah, and LISA is LIGO basically in space, guys.
Yeah. LISA is LIGO in space, and the Big Bang Observatory is LISA squared.
Someone's saying, is there an end of matter?
Well, it all depends. So if the universe is infinite, then no, it just goes on forever. Just what we see in our local area just repeats in different variations forever, right? But if it's finite, then there is a finite amount to the universe, and there wouldn't be an end, because as I said, that 3D game of asteroids, it just wraps. So you go that way and you eventually arrive from this direction. You go this way and you eventually come back from this direction.
And let's see. I'll just have to make a vacuum energy usable.
Sure.
And then Callie, you said,
let me know how that works out for you.
Yeah. Well, wasn't life created because of microbial? Yeah, that's kind of what we're at. Yeah. Where does light come from? Like, really, where?
Stars.
Like, really, where?
Stars.
Really?
Light bulbs.
Like bulbs?
Light bulbs. Light bulbs.
I know. I'm sorry. I'm
jellyfish.
Bioluminescence.
Like yeah. Like, how is a photon generated, I guess, is the question.
Maybe.
Yeah. I mean, that's a whole quantum mechanics conversation.
Yeah, there we go. He might want to go in that. Yeah, that's exactly it. That's a whole thing. Show bulbs. Yeah. Light is just on the electromagnetic spectrum we can see.
Yeah. So, I mean, radio waves, X-rays,
gamma,
infrared, heat. When you're feeling heat, that's just photons that you see with your hands.
Right.
And a photon is a quantum energy that's produced when, there's like different ways that energy can be produced as part of like fusion reaction will generate gamma radiation, which is really short wavelength photons. When atoms rearrange the electrons in their shells, they can release photons. There's lots of ways that photons are generated.
Yeah.
At different wavelengths.
Right. Magnetism is technically photons too, apparently. Even though I can't.
Yeah, really, I mean that's why it's called electromagnetism. So it's just another form.
Someone said, "Dark is the presence without photons. Thank me later."
There you go. It's the speed of dark.
It is. But it is kind of the end here, and I do want to let you get back. You've got a busy.
I got a pack.
Yeah, you've got a busy day, and also congratulations on the 500th anniversary. So 500 episodes, guys, of Astronomy Cast.
Yeah,
that's amazing. So, guys, if you're
interested, we just dropped a new QA. Just moments ago. So that just hit my channel. We're working on another episode about Pluto, New Horizons, what comes next, a return mission to Pluto. And I just wrapped up a whole episode, writing an episode on the Ice Cube Neutrino Observatory in Antarctica, which is just a phenomenal instrument.
Yeah.
Blew my mind going into the research on that.
So what, you made a video on that recently?
Well, I've written it.
You wrote
Chad
it.
is editing our Pluto episode, and I've written the Ice Cube one, so that's going to be coming out the week after that.
Awesome.
Although we're going to be traveling, so it's going to get tough to produce material while we travel.
Right. Well, enjoy yourself, and thank you again so much, and we'll see you very, very soon.